Okay, this lesson is going to be coupled with the next lesson, the coordinate plane. In fact, I'm going to be talking about it first and then telling you how absolute value relates to it. So go ahead and put those in the same set of notes, and we'll be spending the rest of this week working on these two concepts and using the concepts that we learned in lessons 1 through 3. So first of all, we need some working definitions, and let's start with absolute value. Simply put, it's the distance from 0. We'll talk about it later, but there's a good definition, simple, and we'll use a lot, right? Coordinate plane. Now we're in lesson 5. If you are looking along in your book, we're on page 276. So I'm simplifying these definitions a little bit. So coordinate plane is where we intersect. There's a good word. The x and y axis. There's a very simple definition. We've had origin before. That means 0. Another way of saying 0. Or the very center. Quadrants. And these are the 4 regions of the coordinate plane. And there you go. There's our working definitions. Okay, now let's, we're first of all going to look at that coordinate plane. So we're on lesson 5. All right, so it looks like this. You see we have an x and a y axis. We have, for everything else in the past, only used the first quadrant. And yes, you do have to memorize these. Normally we write quadrants with Roman numerals, so there's quadrant 1. And in quadrant 1, both x and y are positive. So if you were writing a coordinate pair, they would both be positive. Then looks like we go backwards, but it's like a C, the letter C, same direction. So quadrant 2, this is where x is negative, but y is positive. And then we go down to coordinate 3, and this is where they're both negative. And then coordinate 4, and this is where the y is negative, but the x is positive. Okay, now, these are simply called the 4 quadrants, and of course you know in Spanish, that sounds like cuatro, which means 4, or in English, quarter, which also refers to a fourth of something. So there's a new term that you need to be using and memorize. And you also, of course, need to memorize that right in the center here. We call that the origin. All right. We've done this before, so this really isn't new, but we're going to quickly review what that looks like. So let's say I'm going to put some points on here. We'll call that A, and we'll put one over here, and we'll call that B, and we'll put one down here, and we'll call that C, and one right there, and we'll call that D. So we should be able to give a name or an address to all of these points as they relate to the distances from 0 on both the x and the y axis. So, of course, it's nice to number these things. I never number every line because that just takes too much space and too much time, but I definitely number enough that you can find things. And of course, everything here is negative. And down here, everything's negative. And there's no great place to write it. Usually we just kind of write it right on top of the line so that it shows. And normally that works fine. It helps usually to use a different color so that the numbers that you put for marking your number line are different from the numbers you use for your coordinates. All right, so here's a coordinate pair for A. So we're going to count over on the over on the X. X is always first because it comes first in the alphabet. And then go up the Y. So it's over 6 and up 5. So this would be a 6, 5. Both positive. Now we'll find the B. The X is first, so we go back 3. So it's -3 and up 1, 1. C, the X first, back to a -7 and down to a -2. And then D, X first, positive direction, 5, and then down, looks like it's in the same. All right, so I want to talk about now D, because D leaves us with our very last, and I'll change to the next screen so we can see other examples. All right, so we had something here where it was, I think it was right here, which was a 5, and then down 5, so it would have been right here. Okay, and we called this 5, -5. Well, let's go ahead and put one up here. And you notice that this should look like it is in the same position, but in a different coordinate. Same thing over here. And this should make a perfect square. And then you can tell where the next one is going to go. I think I'm counting right. Yep. Okay, so we've just made a square. We connected the dots. But all of these have something in common. And that is the fact that they are all of equal distance to 0. And that was our definition for absolute value. So let's just look at this. So if I go from a +5 back to 0, 5 spaces, it's going to be the same as if I go 5 spaces this way. 5 spaces. Or let's say if I started up here on the y-axis and I went down 5 spaces. Or if I started down here on the y-axis and I went up 5 spaces. The absolute value of all of these numbers is 5. So this is how we write it. We say the absolute value of 5 equals, let's erase that because that was a bit sloppy. These are not parentheses, they're straight lines, like that. So that's the absolute value symbol. And then its value is +5, meaning it is 5 steps away from 0. And then I can write -5 like this. The absolute value of -5 is 5. Doesn't matter if I'm on the x-axis or the y-axis. Now, what I cannot say is the distance from here to here is the absolute value of 5. Because if you measure it, it's actually a longer distance. So we always measure towards 0 on either the y or the x, not from any other point on our coordinate plane. So just so that you understand the difference, absolute value is always on either the y or the x axis not in between. It's always on the edge of the coordinate plane, never in the center. All right, so we are now going to do a little bit of practice so that I know that this makes sense to you. And let's start with the absolute value practice. And we're going to be doing both of these in class together. In fact, I really want to have this whole chapter be one big idea for the rest of the week. So I think this is it for the new concepts that we need. So let's do some practice on page 271. And you see in the middle, it says copy and complete the statements using less than, greater than, or equal. So you're asking yourself on number 7, is the distance of -4 from 0 less than, equal to, or greater than the distance of -2 to 0? Now notice, this is really interesting because the absolute value of -4 automatically becomes a +4. So what we're saying is this distance, +4, is greater than the distance, -2. So watch out, because only one of these is going to change. You could have an absolute value compared to another absolute value, and I don't think they're doing that this year. Maybe in 7th grade you'll have that. No, I see on the next page you actually do have some of those. So make sure you know, are you thinking of it as simply the distance between a number and 0? In that case, it doesn't matter if it's negative. Or are you thinking of it as a negative distance to 0? Or a positive distance to 0? All right, so you're going to do those 4, 7, 8, 9, and 10. And then you're going to go back over to lesson 5, where we're going to put some coordinates on a graph. And I would like you to start on page 277. And there's again 4 of these. And notice that some of them are integers and some of them are fractions or decimals, which can equally go on a coordinate graph. Hopefully you are, well, these are small numbers, so you could probably draw your own, but I would suggest using graph paper. There's only so much you can get from me. I can't supply you with graph paper for all your homework, so it would be a really good idea to have graph paper to do that. But for these 4, you probably can get by without. So that gives you 8 problems to practice, and then we'll see how you did tomorrow.